don't buy a pig in a poke. What does it mean, Jędrzej?
Nie kupuj kota w worku.
Good. It was in Polish, but how to minimize the business risk when you invest in nitriding or any other heat treatment technology? Jędrzej, how to do it?
I will show you later on. Let's go.
Gentlemen, what problems occur due to wrong technology selection? For example, like nitriding technology.
Well, we can mention a few of them at least. Yeah? Mainly what can happen is the problems with the production cost, which grows a lot.
So first surprise, you can see bigger cost than you expected.
Yes,
Okay.
exactly. Mainly operational cost. That is first issue. The second one, I would say, quality problems. With all requirements for the process, like hardness, like layer composition, and so on.
Hardness uniformity in the batch.
For example.
Okay.
And the third one, which pain a lot, it's the start of the production. Usually, the layers are quite big in such a case, and what is most important is difficult to predict when we will be able to start the regular production.
I can imagine someone buys the furnace, install the furnace, but instead of doing the production, they are still developing the right technology.
Exactly, and it takes a lot of time, which means a lot of money just wasted for the trials.
Guys, what are typical customer dilemmas in terms of nitriding process?
Quite often we get the question if the nitriding layer can replace carburizing.
Okay. And any other?
Yeah, I think
Just like example.
Yeah, the second thing is if nitriding can be replaced by ferritic nitrocarburizing. This is also very often a big question, but these technologies are different. So ferritic nitrocarburizing offer much better corrosion resistance, and in this application, ferritic nitrocarburizing is better than nitriding, and also faster, so it's cost efficient more.
Marcin, we can imagine that we can have much more dilemmas, customer dilemmas, and imagine we have a number of questions. How to answer, how to make our customer confident. Now we try to discuss about this. So what is our solution?
Obviously, tests before the implementation.
So we have furnaces on our R&D hall when we can make a trial for our customers. So
I mean industrial scale.
Yes, in standard furnaces for our production. So we can make nitriding, carburizing, brazing trials, and also heat treatment, standard heat treatment processes.
Perfect. This is something we can do, like a real process, but can we measure or test or make any report and diagnosis? How it is?
Yes, we can make a process here, and then we can go to the laboratory and we can check the results and prepare the report for customer.
So let's go to the laboratory.
Yeah.
So, Marcin, what are important parameters for nitriding process?
So we have many important parameters in nitriding. So first of all is surface hardness. So surface hardness in nitriding can be measured with different loads. So we can start with a very low load, like 50 grams. We can go higher, like 100 grams. But most popular in nitriding is 1 kilogram. So we have these different methods, and most cases it's a Vickers hardness testing mode. So we are checking the hardness by Vickers method.
On the surface?
On the surface, yeah, that's right. But also in case of effective case depth, we are measuring the effective case depth by hardness, and also in this case, in most cases, we are using Vickers method. With 100 grams, I would say is the most popular, sometimes 200 grams, but it's the most popular method. The second method is the Knop method. If the layer is very thin, there is a possibility to use Knop method.
Thin layer in nitriding, what do you mean?
Like below 0.1 millimeter, something like that, yeah. Because standard layer in nitriding do not exceed like 0.3, 0.4 millimeters. So 0.1 is a thin layer in nitriding.
how about microstructure? Can we see the microstructure here?
Yes, we can see the microstructure here. And in nitriding, it is a bit different compared to carburizing, because microstructure differs after the nitriding, because we have different zones after the nitriding process. So we can see whether we have a white layer after the nitriding process or just effective case depth. So it is important to that we are able to see these layers and check if there is a epsilon layer, for example, or gamma prim layer, because it's they have a different application in case of nitriding.
Marcin, and I know that you have a lot of possibilities and different equipment here, but I know also that how we support our customers is not only the report, but it's also the suggestions on recommendation from our side.
Yeah, that's
technological
right.
support.
Yes, we are offering technological support before we sell the furnace, so we can support our customers to choose the correct technology, to choose the correct layer also. But
to
also
avoid choosing wrong technology.
Yes, that's right. That's right. But also after customer buying our furnace, we can also support in the after sales, I would say, support. So then if customer change the material, if you want to change the layer, we can also support this, and we can choose the correct parameters for this kind of processes.
So if the customer will have new parts to heat treatment, is it how we do this? How it looks later on?
Yeah, so the customer can connect us. We can prepare the trials for them. We can make the process, or if we already knew the material, we can just support in case of email or phone call. So we can choose the correct parameters and support this.
It sounds reasonable. In my opinion, as a conclusion, it's like having a nitriding or buying nitriding furnace without testing before. It's like driving a car blindly, don't you think?
Yes, it could be this way, but to avoid it before the investment in nitriding process, I would recommend to find a partner who can provide you not only the furnace as a tool, but who can provide you the full technological support.
Ideal summary of today's episode. Thank you.
Thank you.
Thank you all.